The question is, what is the mass of barium sulfate that is precipitated after a solution containing 5.55 grams of barium chloride is reacted with excess magnesium sulfate?
The question is, calculate the mass of barium sulfate that is precipitated when the solution containing 5.55 grams of barium chloride, BaCO2, is reacted with excess magnesium sulfate. Okay, so step 1 will be to calculate the amount of moles of the reactant. So let's write down step 1. So step 1, calculate the mass of the reactant. So calculate the mass of the reactant. Now in this case, when we say mass, I'm talking about moles. So we want to calculate the amount of the reactant. Now in this example, the reactant is barium chloride. Now let's write down the equation. Now you're given the equation. Let's just say it's BaCl2 and it is aqueous. BaCl2 plus MgSO4 and AQ, and that gives BaSO4 solid. That should just be S plus MgCl2 aqueous. Alright, so let's say that you're given this equation, and the amount of barium chloride then, if we use the formula, because this is the reactant, right? This is the reactant. Okay, so the reactant, let's convert into moles. Now we know it's 5.55 grams of barium chloride. 5.55 grams of barium chloride. Okay, so if we use the equation, amount of barium chloride, and that is mass over molar mass. And that is equal to 5.55, and what's BA? I need to find, hold on. Alright, so barium is 137.3, chlorine is 35.5. So if we added another 35.5, we would get 13, 11, 18, carry the 1, 208. So it would be 208.3 grams per mole, and this one's grams, right? So it would be 0.0264 0.2664 moles. So we've converted the barium chloride from grams to moles. Now if you look at the equation, so the equation is 1 mole of this plus 1 mole of this gives 1 mole of this and 1 mole of that. So the ratio is 1 to 1. So that means 0.02664 moles of, the question is asking you for calculate the mass of barium sulfate. It's asking you for the mass of barium sulfate. So 1 mole of this is produced, right? and it's also 0.02664. So hold on, so the mass of barium sulfate, BaSO4, is equal to well, let's work out first. Alright, so sulfur is 32.1, oxygen is 16. So 137.3 plus 32.1 plus 4 lots of 16, and that will give you 2334 grams per mole. And now if we just use the equation, if we use what equation do we use? We can use the same equation up here. So the amount of that product is equal to the mass divided by the molar mass. So we want to work out the mass, don't we? So we want to work out the amount of we want to calculate the mass of barium sulfate. So we want to calculate the mass. So we want to calculate this. Do we want to calculate this? Because we've got this moles. We've got this mole. So that we got that, and we have the molar mass. So what we have is that we've got moles and molar mass. Okay, so mass of BaSO4 is equal to moles times molar mass, and that is equal to 0.02664 times 233.4, and then your answer should be 6.22 grams.
Alright, so step 1, you would calculate the number of moles of the reactant, and in this example the reactant is barium chloride. That's step 1. So you've got the mass of barium chloride, which is 5.55 grams, and you want to work out the number of moles. So to work out the number of moles, you divide by the molar mass. So 5.55 and 208.3 is the molar mass of barium chloride. So that's 208.3. So 5.55 divided by 208.3 gives you 0.02664 moles. Now for step 2, the ratio is 1 to 1. So the ratio of barium sulfate to barium chloride is 1 to 1. So the amount of barium sulfate produced and the amount of barium chloride is the same, 0.02664 moles. And then step 3, you convert the moles of the product back to mass. So in step 3, you have the molar mass of barium sulfate, you add the barium, you add the sulfate, you add the 4 oxygens, that gives you 233.4 grams per mole. And then because now you have the molar mass and you have the moles, moles times molar mass gives you the mass of barium sulfate produced, which is 6.22 grams. 6.22 grams.